Alright guys, welcome to this page of the notes, and again we're working on hyperbola where I give you some information but you look at this and you go, what is that? Well, I've given you the asymptotes and I know it looks ugly, but I promise you it's actually, this one's I think much easier than the one that we just did. And here's the reason why. The equations for the asymptotes, well, they're linear lines. It's just a straight line, so it's always going to be in the form y equals mx plus b. Check this out. I have y equals mx plus b, right? Where m is 5/3, that's my slope. My b is on the end, but I don't have a b, so that means that b is 0. And then this one as well, y equals mx plus b, but there is no b, so b is 0. So these are actually really easy to graph. Both of the lines will go through the origin because b is 0. My y-intercept is 0. And each of those lines, when they go through that y-intercept, are going to have a slope of 5/3. This one will have a slope of minus 5/3. So let's go ahead and just graph those asymptotes right away. I'll do them in red. I start at my y-intercept, which is 0. My first one, I will go up 5 and over 3. Up 5 over 3. That works so well, I'll do it again. Up 5 and over 3. But remember, it's exactly the same as going down 5 and back 3. So I will go down 5 and back 3, down 5 and back 3. And you can go ahead and draw a dotted line through that guy. Right through there is an asymptote. All right, my other line, again, b is 0. So my y-intercept is 0, but now the slope is minus 5/3, which means down 5 and over 3. So I start at 0, I go down 5 and over 3. That works so well, I'll do it again, down 5 and over 3. But that's exactly the same as going positive 5 and minus 3. Well, let's do that. I'll go up 5 and back 3, up 5 and back 3, and look at that. There's my other asymptote. Let me draw a dotted line, dash, dotted, whatever you want to call it, through that guy. So, now that's graphing, right? That's graphing my asymptotes, which are in slope-intercept form, y equals mx plus b. Now, I've been given vertices. All right, let's graph my vertices. Okay, so that's going to be 0, 5. So 1, 2, 3, 4, 5. Right there is a vertice. So that means that right there is a vertice. Remember, vertices are always on the transverse axis. So my transverse axis runs right through there. That means my transverse axis is vertical and my origin is the center. So that tells me that I need the equation y squared over a squared minus x squared over b squared is equal to 1. Okay, well, let's go ahead and graph the hyperbola first, then we'll go ahead and finish this guy out. Here's how we're going to do it. Draw the rectangle first. The rectangle must go through. The rectangle must go through the vertice and through the co-vertices. But it turns out that that very first point you plotted is the co-vertice. How do I know that? Well, check this out. Go to the formula sheet and find, right, for a hyperbola centered at the origin, aligned vertically. What is the equation for finding the asymptote? Well, if you go to that, you're going to get that y is equal to a over bx. Actually, I apologize. It should say, oh, sorry, hang on, let me squeeze. There should be a plus or minus in front of that. Plus or minus a over bx. Again, the reason there's a plus or minus is because I have a plus 1 and I have a minus 1. But here's the point. The point is this. What is a? Well, we already know a is 5. Where's the 5 right there? So what you know is that this guy right here, that guy right there, is your A. So what's that guy? It's your B. That's B. So here's what we know. We now know that A is 5, B is 3, and you could find it a couple of ways. I know that A is 5 both from the fact that I have the vertice right here, which gives me A, and the fact that I'm given an asymptote, where I know A is the numerator and B is the denominator if my parabola is centered at the origin and oriented vertically. And again, all that stuff comes right off of the formula sheet. So, since B is 3, that means that my covertices are 1, 2, 3 right there, and 1, 2, 3 right there, which, right, is the point that I already had just by putting my slope in. Why? Well, because the slope has B in it, right? It has B in it. Anyway, I love all that cool little stuff when it works out. I love it when algebra makes sense. Again, please notice that my asymptotes run from corner to corner through my box, that rectangle that I just drew, and your hyperbola must go through the vertice and it can't touch the asymptotes. So that's going to be this guy right here and this guy right down there. Hey, go ahead and write your equation. Y squared over A is 5. 5 squared is 25 minus x squared. B is 3, but I need a b squared, so 3 squared would be 9. That's all equal to 1, and that is the equation for the hyperbola that we just graphed right there. Using the asymptotes, I didn't even need that Pythagorean theorem, which is why I think this one's actually a little bit easier than the last one we used. These are just linear lines. They're in y equals mx plus b. It couldn't be easier. That's going back to chapter 1 of Algebra 2. You should be okay graphing linear lines once you've got the slope and the y-intercept. And then that gives you A and B, which you just drop right into your formula, which you take off the formula sheet. Really, really pretty straightforward and easy problem. Head on over to the next page of the notes. We'll take a look at another one. I'll meet you guys there.